for this project, we have utilized Kaggle's coronavirus Twitter data, the historic data. So first of all, we've imported the respective files from Kaggle into our collaboratory. Moving on, we've also imported the rest of the packages required, like random oversampler for removing the oversampling, count vectorizer, multinomial knife bias with which we will be training our data set, the BERT tokenizer. Since here in our project we have used three particular models to train our project. One is the random forest, one is multinomial knife bias, one is support vector machine, and also to capture the integrate details within the word vectors, we have also utilized one transformer based deep learning model of BERT. So moving on, here we have defined the confusion matrix for each of the particular model, and after training the models we've done an ensemble of all these classifiers, and we've come to the conclusion that random forest outperforms them and performs the best. So here we have loaded the CSV files within the data frame, and here we are visualizing the first 5 rows of our data set. We can see that the columns which we are having are username, screen name, location, tweet at, original tweet, and sentiment. Here, the sentiments which we'll be dealing with are neutral, extremely negative, extremely positive, negative, and positive. So we can see the information of our data set. So moving on, let's go with pre-processing. So pre-processing is very important since it will make sure that our models are not overfitted and that the learning curve is smooth. So we'd be first of all dropping any duplicate values or cells which are present and replacing not a number values or empty cells with prominent values. And after pre-processing and dropping the duplicates, which we are doing in cell number 9, we have again visualized the information of the data frames, and then we are analyzing the tweets per day in a visual manner. And when we analyze this, tweets counted by days, if we analyze this visually using matplotlib, we can see this data. So we can ascertain that on 3 by 39 92 tweets have that is the maximum value reached in our data. So this particular data ascertains to only the dates which are present in our data set. So among all the tweets made on the dates present in our data set, 3 by 13 is the date on which maximum number of tweets have been made by users. Moving on, we are now gonna go towards the testing set where we are taking the original tweet as well as the sentiments into consideration, and then the most important thing, some most important thing about data pre-processing is the cleaning of data. Here we'd be removing any kind of emojis which are already present. Here we'd be removing the emojis which are present in our data, and moving on, we'd again be stripping and splitting it into variables, and also we'll make sure that unnecessary random letters or unnecessary random characters are not present in our data set. So after that, we'll be filtering based on the above pre-processing steps, and then we'll be concatenating that into a new data frame, and that would be our pre-processed data set, which we'll be feeding into our models. So moving on, after cleaning the dataset, our dataset looks like this. We've again printed the top 5 rows of our clean dataset. So moving on, here we are plotting the training tweets with less than 10 words, and we can see that 24 tweets are present with 9 words, which is the maximum, and in third and fourth, just 1 tweets are present with 3 and 4 number of words. And again, the tweets with less than 10 words within the testing data set is again kind of similar. So we again have 24 number of tweets with exact 9 number of words. So moving on, we are printing our cleaned data frames shape and test data sets shape and feeding it. Now we are initializing our tokenizer with BERT model. We are taking this from Huggin Face's transformer based open source models. And after tokenizing the words which are present in our data set, we'd be printing the tokenized sentence length, which we are getting as 96. So Moving on, when we are again visualizing the data set after clean, so we are seeing that this is our original tweet. These are the sentiments. This is exactly the same tweet but with the clean text, and this is the text length and the token length which we've taken out using the tokenizer function. So moving on, okay, so here we have visualized certain values and certain data from our data set, and again we are printing the top 10 data frame from our data set. So moving on, we are again printing the sentiments. So we are seeing that we have 831 data samples with negative sentiments, 753 data samples with positive sentiments, 490 data samples with neutral sentiments, and 483 data samples with extremely positive sentiments, and 463 data samples with extremely negative. So now we'd be using categorical values, and we are initializing the negative to 0, normal negative to 0, neutral to 1, positive to 2, and extremely positive to 2 for our prediction. So now we do not want any outliers to be present in our data which would dominate the performance of our model. So we'd be using random oversampler to make sure that oversampling does not occur. And moving on, we'd be splitting our data set, and here test size is 0.1%, so we've split the data set in 9:1. And moving on, we are pre-processing using one hot encoder, so we use this particular label encoding in our solution. And finally, we have the training data as 3493 samples, the validation data as 389 samples, and the testing data as 3027 samples. And again, we are initializing the count vectorizer, and we are fitting in the X train and the X test. So moving on, after doing this, we'd be calling in the multinomial naive bias and feeding it into this data, and we are seeing that these are the metric scores which we are getting uh, with the multinomial naive bias like model. And if we see the ROC curve, then we can see that our data is well trained, our model is well trained with the clean data set. And this is the classification report for naive bias, where we are achieving an accuracy of 90%, which is a really good accuracy. So for the second model, we have used the support vector classifier, and here again, when we are training the same data, same clean data, and same features which we have taken for the x-axis and the y-axis within the support vector machine, we are gaining, these are the metrics we've obtained in precision, recall, F1 score, and support. We are gaining an accuracy of 93%, which says that SVM is performing better than the multinomial naive bias. And moving on, we've printed the ROC AUC curve for support vector machine also, and we can see that the loss has been well captured by our model while training itself. So moving on, we've also added one deep learning transformer based model, which has in traditional forms has performed really well in recent researches when it comes to textual data and the field of natural language processing. So here we've used the bird based uncased model from Hugging Face, and after defining, this is the model summary which we are printing, where the total trainable parameters are 109484,547, and we are feeding our data set into the model with 4 epochs and batch size as 64. Here we can see that the categorical accuracy has come to 97.71%, validation loss as 90.47%, and the validation categorical accuracy as 76.35%. So here we can see that our above machine learning supervised models have performed better than BERT, and here we've printed it for BERT model, our accuracy and loss curve. So we can see that as the data is gaining and as the model is training itself via the epochs, it is gaining accuracy, and the loss has also reduced over time. So okay, let's move on. So moving on, this is the confusion matrix for the bird that we have printed, and this is the classification report for bird. And moving on, so we've combined our model into our 3 or 4 algorithms into the final combination of ensemble learning, and the final ensemble which we are getting is an accuracy of 94%. So we've also trained one more parameter, and we've added one more parameter and trained one more model, that is random forest classifier. And when we are printing it, we are getting this particular data with an accuracy of 96%. And this is the ROC curve for training the random forest model. Moving on to understand and explain the interpretability of how our model is really performing, we've added shapely values. We've used shapely values, and we've tried to implement a SHAP with explainable artificial intelligence to see, to understand that why our model is predicting what it is predicting. We know that machine learning models are actually black boxes, and to understand the interpretability of the model, explainable AI has gained significance in recent times, which is one of the novelties of our implementation. So we can see that the best performing classifier is random forest. So the best performing classifier has been undergone the SHAP implementation, and we can see that the features, most of the features have gained a higher probability of affecting our model's performance, and some words like over, panic, control, these are less affecting the performance of our model.